So let's go into a bit more details on what exactly can we do in the energy sector on campuses to reduce carbon footprints and in fact head towards net zero. As universities and colleges are used for working, studying, teaching, and in some cases living, they consume significant energy to power lighting, technology, appliances, hot water, water supply, and space heating or cooling. Electricity generated from fossil fuels is generally the primary source of the university emissions, and so on. So we here look at the 4 pillars of decarbonization framework, which are recommended for which recommends 4 different approaches to reduce carbon emissions. The first is to start with avoiding and reducing use of energy from fossil fuels. The second approach is by shifting to renewable energy. When the grid is powered by renewable energy, further electrification from non-renewable fuel sources is recommended. The final pillar is to reduce non-energy emissions through carbon capture and offsets after efforts across the other 3 pillars have been exhausted. So here are the 4 pillars of decarbonization, and here it is: energy waste reduction, including through energy efficiency and a shift away from energy intensive products and services. So oftentimes if you are in an old institute which is decades old already and has a lot of infrastructure, computers, machines, lathes, other labs and so on, which are old, dodgy, kludgy, electrically inefficient appliances, you have to think of maybe retrofitting depending on financially viable plans. And of course you want 100% renewable electricity if possible, but is that always possible? Maybe not in your hands. Electrification and a shift away from fossil fuels to zero or near zero emissions. Again, each one of these is kind of an innovation opportunity for an academic campus, right? Non-energy emissions reductions, offsetting, fuel switching, and others. So those are the 4 pillars. Sound kind of too broad, but yet they are applicable on all campuses. So reduce energy demand on campus. So reducing energy use and improving energy efficiency of university and college campuses should be one of the early actions to implement in a net zero plan. So these are what you would call no regret decisions, low hanging fruits that you know there is no negative outcome in reducing energy use and improving energy efficiency, right? Reducing energy demand also covers improving energy efficiency, such as retrofitting campus infrastructure to be more energy efficient, but this can mean financial resources needed and cost benefit analysis of upfront cost of retrofitting versus the benefit you gain in terms of market and non-market benefits, as well as a whole suite of green campus initiatives such as sustainable transport, demand response options, and switching to less energy intensive equipment. Whilst energy saving measures should be paired with sourcing energy from renewable sources, alone they can be cost-effective, a cost-effective way to reduce the overall energy demand of a university. So here are the benefits, challenges, and measuring impacts. The benefits: targets key source of scope 1 and scope 2 emissions. Resource conservation is always important. Energy security for the university or college and community. Immediate as well as long-term financial savings and overall community benefits, including cleaner air, climate change adaptation, and mitigation. Oftentimes on campuses you are running computers, simulations, labs, etc., or even air conditioning for certain lab experiments and so on, and you need continuous energy supply. And in a country like India or many other developing countries, energy supply may be quite unreliable, so having energy security and renewables on campus, especially with a microgrid and maybe energy storage, you can really become quite independent of the outside grid, which can be very critical. Challenges, of course: resistance to change both at systemic and individual level, inability to recognize long-term financial benefits, which comes down to some leaders and governance bodies to recognize this long-term vision and enforce it, appropriately. Lack of financing for upfront costs when you do, especially when you want to do retrofitting. Non-availability of energy efficient alternatives, especially in low and middle income countries, can be a big issue. And lack of data to make sure you are moving in the right direction, or where your levers are in terms of increasing efficiency, reducing energy use, etc. Skills and capacity within the university or college. And then measuring impact, you can always track emissions like CO2 equivalent, so you want to track all greenhouse gases. Reduced energy consumption in kilowatt hours is easy to measure. Cost savings in reduction in electricity bill and fuel costs can be easily tracked, and flattened energy consumption patterns as well, right? How to reduce energy consumption of a Sorry, as I said already many times, I'm having serious allergy issues. How to reduce the energy consumption of a university or college. Switch to LED lighting, use equipment with energy efficiency ratings, minimize heating, ventilation, air conditioning or HVAC run times. Fairly low hanging fruit and no regret decisions. Utilize smart and automated technological solutions to improve energy efficiency. This could include mobilizing the Internet of Things through power saving fixtures, meters, appliances or equipment, installing occupancy sensors, or even utilizing district energy sources. So these sensor lights which come on and off by themselves, or water use that is also sensed, can all save a lot of energy, water and so on. Reduce energy demand by encouraging behavior change, so turning off lights when not in use, avoiding overuse of heating and cooling, shutting down computers, etc. But of course here again IoT can automatically reduce energy demand. Use energy management systems to manage demand, install demand response programs and coupling of solutions such as renewable energy programs and electric vehicle charging. Involve students and staff to implement energy savings initiatives and campaigns. And campaigns can be run between floors of a building. Academics can bring their expertise into facilities, data analysis, etc. Explore innovative solutions such as altering the academic calendar, as adjusting semester dates to fit working days with milder seasons could reduce energy requirements. Similarly, reducing the number of operational days for campus facilities could improve energy use and efficiency. So in a country like India, which is very hot, this is not so easy to do, but things are kind of set towards what to do during heavy rain season, what to do in the summer, which is March, April, May, and so on and so forth. But we have basically very high temperatures, especially in a place like Mumbai, all the time. Replace fossil fuel dependent appliances. So obviously appliances that currently use fossil fuels such as natural gas in developed regions or diesel used in global south emit large quantities of scope 1 emissions. Diesel is also deadly dangerous for health. To reduce these emissions and safeguard against higher energy costs in the future, universities and colleges will need to transition to low carbon sources of energy and electrify their heating and lighting appliances. Although the electrification of equipment will incur replacement costs, these can be counterbalanced by lower operating costs, especially if renewable energy is used. So there are many such examples. Let's look at how to transition away from fossil fuels in a few bullet points. Implement energy reduction initiatives first to reduce the scale of transition required. So whatever your source, first try to reduce energy demand, energy use. Use heat pumps instead of natural gas, which works very well for cold countries, mid-latitude countries. Heat pumps are basically things that work differently than air conditioners, where they take outside energy and provide heating, or take inside energy out to create cooling. So they are much more energy efficient and so on. Ensure that the electricity used is sourced from renewable energy. Where renewable energy is not viable, consider fuel switching to less carbon intensive fossil fuels. So LPG is much more efficient definitely than diesel, for example. Coal you don't want at all. Biogas from campus organic waste can be an affordable source of energy for many parts of the world. Hydrogen may also be a viable fuel source. If making the switch to hydrogen, in making the switch to hydrogen, it's important to ensure adequate supplies of green hydrogen. So when you split the water, it's a very expensive process, but if you use renewable energies, then obviously you can produce the so-called green hydrogen. What are the benefits? Targets key source of scope 1 and scope 2 emissions, resource conservation, building energy security for the university. Did I already read these things? Why do I have it again? Okay, we are just repeating some of the points but slightly different. Building energy security for the university or college and community, immediate as well as long-term financial savings, overall community benefits including cleaner air, climate change adaptation and mitigation. Challenges: lack of alternatives to fossil fuels in low and middle income countries, especially ensuring reliable supply chains of new fuels and equipment. Resistance to change both at systemic and individual levels, inability to recognize long-term financial benefits, lack of financing for upfront costs, lack of data, skills and capacity within the university or college. So very similar sounding ones, same ones, but some additional ones in this very context of replacing fossil fuel dependent appliances or transitioning away from fossil fuels. Measuring the impacts again: reduced emissions of CO2e, reduced energy consumption, cost savings, return on initial investments, and reduced emissions intensity of the energy sources. Okay, so maybe we can continue. It will be a bit long, but maybe I should split it. So let's come back and read this in the next podcast, because this one is already 12 minutes long. So attention span is supposed to be about 7 to 10 minutes, so I try to keep them somewhere just beyond that, because 7 minutes is too short. It will be too many podcasts. So here we are. Okay.